Hello students, we have been discussing about the power generation systems subject for the from the previous classes. So in that we have discussed about different sources of generating power, both renewable and non-renewable sources. Hydrothermal scheduling is the very old scheduling in practice. Okay, so first of all, the scheduling is very essential because so if you take a country or a state, so all the sources are connected to a grid. Okay, so there is so much amount of demand for a overall state, and for meeting that demand will connect so many power generating sources to the grid. So start with the practice. Our usual practice was hydropower majorly and thermal power majorly. So this is the old practice before coming to the these renewable energy sources. Now we are scheduling with the solar energy, with the thermal energy, with the wind energy. This is in progress. For instance, still so many places we are keeping the solar energy, wind energy as the backup for the main source of energy. Still. So whatever it may be, this is a hybrid scheduling. So if I am meeting the demand only on the hydropower or thermal power or wind power or solar power, so whatever may be. So I am depending on single source. So depending on single source is very unreliable and also very difficult. So even for today, 40 to 50% we are depending on the thermal energy, and slowly, of course, next we are majorly depending on hydropower, and slowly the share of the renewable sources of power generation is increasing slowly, consistently. So when talking to this hybrid method of scheduling, so this helps us for balancing the loads. This helps us for grid stability majorly. So our first aim is to maintain a reliable, constant, stable supply for maybe the industrial load, for maybe the agricultural load, for maybe the commercial load, for maybe the domestic load, or maybe for the municipal load. So whatever the supply which we are giving, it should be reliable, it should be uninterruptible, it should be constant, it should be stable, and it must be cheap. And it should be available everywhere, every village, and every street, every city. So having this much of big task in front of a supplying system, we cannot rely on a single type of power generation. So for that reason, in the starting itself, even in the non-renewable sources or in the conventional sources itself, this hybrid method of scheduling came into existing. And today, the hybrid means the scheduling, we are scheduling with hydro, thermal, wind, solar, whatever may be available energy from the waste, all these sources, we are able to meet the demand constantly and reliably and uninterruptedly. So today we will discuss about the starting hybrid thing, hybrid method of scheduling, that is hydrothermal scheduling. So why can't we have to? Why can't we still 100% rely on thermal energy? Means yes, we can rely, but they needed a back support system. At peak times, we may not be able to meet. So for all these reasons, the hybrid method of scheduling came into existence. So hydrothermal and scheduling especially very very good, because even for today, if we ask what is the clean, what is the cheap source of energy, what is the multiple sources, multiple task project power plant, means we can only say with a single word, that is hydropower. That is the hydropower. Hydropower is also a green energy. Nowadays, so many people are telling green energy and making the advertisement such that people are thinking green energy means only solar energy or wind energy. Hydropower is the actual green energy which is not giving producing any pollution in its existence, process of existence. Even I can say, even the solar energy, even the wind energy, if you are preparing, for example, I take a wind energy, if you are preparing a wind turbine, there is so much amount of fiber involved in that. So in the making process, you are going to release so many chemicals, toxic chemicals into the earth or into the atmosphere. Even the solar energy, if I say, a large involvement of plastic is there in the making process of the solar energy and making it as economical cheap source. So even in its production process, so much amount of poisonous gases and chemicals have been released. Okay, coming to this topic, hydropower is very good plant which is multitask and also cheap and also clean also. So no pollution is evolved. So it is good if I am able to meet the entire demand the hydropower, but which is practically impossible. No country in the world, no state in the world have that much of hydropower which can be available 365 days a year. especially in the country like India, because we are in monsoon region. So we'll be having surplus amount of water during the rainy season, and we will face the scarcity of water during the summer season. So even if we are at Himalayan region also, during the winter season we will face the scarcity because of the snow, because of the freezing. So whenever there is surplus amount of water available in the dams, it is better more to rely on the hydropower. So at that time, we will produce more amount. Majority of the power, the majority of the demand is met with the hydropower, and during its scarcity time, majority of the demand is met with the thermal power. So this is the optimal utilization technique which came into existence to decrease the cost of production, to decrease the pollution, to decrease the maintenance cost. Okay, anyway, we'll go into the subject. So both hydroelectric and thermal power plants are used to meet the electricity demand. So nowadays we are having so many more options to meet the demand. The goal is to optimize the operation of these plants. So that is called as the ideal utilization. So it is the ideal utilization. If I am using hydropower more when the water is available more in the dams, that is called the ideal utilization. If I am using more thermal power when the water is less, it is called as ideal utilization. Okay. So to minimize the costs, so by doing so, we are having so many advantages. We can minimize the cost, we can minimize the efficiency, and we can ensure the reliability. So and also we will have the power balance. So it should be such that always the power generated must be equal to the demand, power supply. So even though it is practically impossible, we are able to do it with the help of SCADA. So what are the constraints of the hydropower? The constraints of the hydropower is water availability. So if I want to produce a hydropower, what I need? I need water availability, the head, okay, the storage of water, and we'll be having water discharge limit, and we should have the continuity of water flow. And if I come to the thermal constraints, even for efficiency of the thermal power plant is very, very less. That is around 40% nowadays, even nowadays. So we are having generation limits, and we cannot use it everywhere because of its pollution. So it should be placed away from the cities. So similarly, if I say about the hydropower, I cannot build everywhere. The dam I cannot build everywhere. There should be geographically friendly area. So there only I can construct a dam. So and also ramp up and ramp down rates. So how fast the demand is increasing and how fast the demand is decreasing. So next thing is time horizon. The hydrothermal scheduling can be either short term or long term. So for example, during the rainy season, okay, during this example I am taking, during the rainy season, I am using more amount of the hydropower. If I want to say exactly, there is no need for utilization of thermal power. But suddenly, if the demand increases, so I will utilize the thermal power also, simply for maybe for 1 hour or for 1 month or 1 day or for 1 month. So that situation temporarily, so the temporal utilization we can call it as the short term, and for more the time, if I am in the annual in the year, I'm using more hydrothermal scheduling. So it is called as the long term scheduling. Okay. So that is dependent on the necessity. It is dependent on the necessity and availability of the water. So this is a strategic scheduling. So and also why this is important means, so as long as I am utilizing the hydropower, so I am decreasing the utilization of the thermal power. So for producing the thermal power, for example, coal thermal plant, I need some tons of coal daily and so much amount of water daily. So this fuel cost is decreased and maintenance cost is also decreased. So by optimally scheduling hydro and thermal power plant, the system can leverage the low cost generation. So how much? So always I will utilize the hydropower as maximum as possible, as more as possible. So because the thermal energy is a costly process when you compare with the hydropower. But the installation time cost may be more. Okay, so this can help in low cost generation and reducing reliance on more expensive thermal plants. The thermal plant is expensive, and also this will increase the reliability. Hydrothermal scheduling increases the reliability, because if I am only dependent on the hydropower, for example, take your house. So suddenly the power shortage is there. Simply what you will do? Nowadays the inverter came, but olden days, so we used to have the diesel generators. So similarly, if suddenly any power shortages or emergency cases, we are having alternative. If we are having alternative, that is called reliability. So this scheduling gives more reliability also, and considering the variability of hydro inflows and the constraints of both types of power plants. And next thing is environmental consideration. So if how much less I am able to use the thermal power, that much less amount of pollution I am releasing into the atmosphere. So this is also environmental constraint. So helps to optimize water usage, reducing environmental impact of water resource, and promoting sustainable energy practices. So if I come into the mathematical problems, so there are different. So for this also we are having how we have to do the scheduling. So we are having so many mathematical solution which which are the age old practices, and newly with the increase of the technology and software technology, having we are also using the new methods also. So if I come to the mathematical optimization, there are different techniques. So they are Lagrange's gradient search technique and dynamic programming. So we used to have all these three types of techniques to find. So we will be having the entire year data to study the demand. So based on the demand, we will prepare for the next coming year. So with the based on the data and with these mathematical techniques, so we will forecast the demand and we are going to meet this demand with this ideal scheduling. And nowadays we are going to have this new techniques. This is called as heuristic and meta-heuristic methods. So more recent approaches include heuristic and meta-heuristic methods, which are experience-based procedures for obtaining the optimal. So nowadays we are using these heuristic methods for obtaining the optimal solutions. So they include the genetic algorithm, swarm optimization, artificial honeybee calling algorithm also. So this is about the hydrothermal scheduling. So I have given this as an example. So we can have the scheduling for the wind energy with the solar energy also, along with the thermal energy and hydropower. So which will be better for demanding the for meeting the demand. Thank you. Thank you for listening.
Like, share, and subscribe. Hit the bell icon for more updates.